Why do plants grow better in blue light? When producing a greenhouse crop out of season, or growing plants indoors, it is important to know the most efficient color spectrum of supplemental lighting to use. This helps create the optimal growing conditions for the plants and saves on energy by getting the most usable light per watt. Blue spectrum lighting during the vegetative cycle maximizes the efficiency of photosynthesis for healthy and strong plant growth. Seasonal changes. The amount of blue, red and far red spectrum of light that reaches the planet changes with the seasons. As days start to get longer, more blue spectrum light reaches the surface of the Earth. This initiates a vegetative growing stage for most plants leading into the spring and early summer. As the days start to grow shorter, and more of the red and far red spectrum reaches the surface, it leads into the late summer and fall reproductive season. Photosynthesis. Plants photosynthesize nutrients for growth using a green substance in their cells called chlorophyll. Most types of chlorophyll can use the blue spectrum of light more efficiently than the red and far red spectrums of light. More of the blue end causes the cells to be elongated, changing the growth pattern of the overall plant to a more compact size with the nodes closer together. This maximizes the space used in light available for each leaf in the growing area. Supplemental lighting. When growing plants indoors or off-season in a greenhouse, supplemental lighting is often required. Manufacturers have created lighting in various wavelengths to mimic the growing season spectrum at various times outdoors. Switching from the blue end to the red and far red end creates the same effect as the seasonal changes when growing outdoors. This tricks the plant into thinking the season has changed, and initiates flowering in some species. Color temperature. The spectrum of light is measured by the Kelvin temperature rating of its relative whiteness compared to sunlight. For artificial lighting, a lower rating around 2700 K is in the orange and red spectrum and looks like an orange-colored street light. The blue spectrum is about 4200 K and up. White or daylight, which is the most like natural light, is about 6700 K. Newer technologies allow for the farther blue spectrum of 10,000 K, often called ultra-daylight, up to 20,000 K to replicate light underwater for marine macroalgae and algae and corals. Balance in the red spectrum. Although the blue spectrum is very influential in the vegetative stage, the red spectrum is also important. Some types of chlorophyll respond better to the red end. Tropical and foliage plants primarily need to be visually appealing for display, and some produce flowers all year. A balanced daylight spectrum light, that is slightly high in blue, but still visually white to humans, is used to get a good mix and to render the colors true to what they would be under natural sunlight.